In this ACT video, we are going to review circles and angles, and this is just part one because there are many angles that can be formed within a circle. In this video, we're going to focus on two. Now, before we get started, let's just talk about what a circle is. By definition, it's the set of all points equidistant from a fixed point called the center. And right here, we have circle O. So O is my center. O is the center. And then the segment here from the center to a point on the circle is a radius, one of infinitely many that can be drawn. And then the segment that passes through the center with end points on the circle, CB in this case, that is the diameter. And from those segments, we form many types of angles. And the first one we're going to look at is called the central angle. And it's the central angle because its vertex is located at the center. Center and central, they mean the same thing. And the central angle is equal to the degree measure of the intercepted arc. So let's look at this circle B right here. And we have angle ABC, and let's just call this angle X. Well, angle X is equal to the measure of its intercepted arc, AC. And let me get the highlighter just to emphasize this. AC is the arc right here, and this is our symbol for arc right over those two letters. I could call it arc AC, or I can have arc CA. So central angle, vertex is at the center. That's what you're going to want to look for, is where's the vertex of the angle. The second type of angle we're going to look at is the inscribed angle. And an inscribed angle lies on the circle. So you can see here, angle ABC, vertex B is on the circle. Well, the measure of an inscribed angle is equal to half the degree measure of the intercepted arc. So here I've got the angle labeled as X, and it is equal to half the measure of arc AC. Now that's one example of an inscribed angle. Let me show you another. All right, looking at this example, we have angle PQR. Where's the vertex? The vertex is on the circle, Q. Therefore, the measure of angle Q is equal to 1/2 the measure of the intercepted arc. Well, the intercepted arc is arc PQ, all the way around there. So it's half the measure of arc PQ. So it's very important when solving these problems with circles and angles to ask yourself, where's the vertex located? And once you know where the vertex is located, you can go on with which formula to use. Let's look at an example. Here is circle O, and I just want to know what's the measure of the angle X. So we have this angle. Here's the vertex. The vertex is on the circle. On the circle means it's inscribed. If it's inscribed, it's half the measure of this intercepted arc right here. So X is equal to half the measure of arc AB in this case. So X is equal to half the measure of, well, we don't need the M there anymore. How about just half of 180? And half of 180 is 90 degrees. So we can say that that angle is 90 degrees. That one's pretty straightforward. This next one has a little bit more to it. We have circle A, and we want to know what's the measure of arc BD. Well, let's locate arc BD. This happens to be arc BD right here. And the angle that corresponds to arc BD is angle BAD. And angle BAD happens to have its vertex at the center, which makes it a central angle. So We just need to know what that angle is. If we know what that angle is, then we can find out what that arc measure is. Well, we have the given information here of 120 degrees. That's not the angle we need. However, because, one more highlighter tool here, CD is the diameter, we know that those two angles are supplementary. So we're using some prior information here. We talked about supplementary angles in a previous video. So 180 minus 120 makes that 60. So this angle is 60. So then the arc BD is also, measure of arc BD is also 60, because the angle, which we're going to call, let's not call it X because we didn't have an X in there, but what if we call it angle BAD, is equal to the measure of arc BD. And that's because we're dealing with a central angle. The vertex is on the center. So when you see one of these problems with circles and angles, you need to ask yourself, where's the vertex of the angle? And then from there, you'll know where to go.